we are experts in the design, manufacture, and distribution of fluid system components. Okay? We do not make recommendations, nor do we provide design work,
Right.
unless it's something internally we're going to build a panel for you at the factory in Cleveland, Ohio. But what we can do is provide information on the series and lines of products that we do make, and this is going to be good to 6,000 PSI. We may ask you questions about, like, where is the thread packing located relative to the threads? A lot of people don't realize how important that is, where if you have something going through the line that could wash out the lubrication, then you can't operate the valve. A valve like the PD, the threads are isolated from the system fluid. So the PD valve meets the requirements on pressure, temperature, and it does give you throttling capability. And once again, if we're trying to blow something down or just vent, it's a valve that would no doubt meet that capability. If we're trying to do, cubic feet per minute, probably there's something else there that's a better choice. But that's not what we're doing here, is it? We're just trying to get something out of a coalescing filter so you can dump the pressure.
We have some sort of vapor. We have some water. We have some maybe microscopic metal aspect or something or another that would be caught.
Now,
and I have 45. It's operating at 4,500 pounds of pressure. So it's not a needle valve like you would have an air valve on the
right.
Tire tube, but
No.
yeah, take my finger off.
But this valve provides working pressures up to 6,000 PSI. And one of the other cool things, when we make a product that's very conservatively done, at that kind of pressure, you'd still be able to operate it too. There's many times you buy a valve that's rated to 5,000 pounds, but they're quite often difficult to operate above 3,500. That's not going to be the case here. The Delrin seat also has the ability to absorb a little bit of trash and still function. That's one of the cool things about the rising plug valve. The tapered plug also goes into a tapered receiver, so there's an awful lot of surface area there. And you can see that by the little picture I had here for you.
So how about cost? Is this cost more than a needle valve?
Well, we have various needle valves. We have some that are basically. That's a great question.
Well, the question here is there's been enough compressed natural gas fueling stations built around the country that have Swagelok fittings in them, because you're here because you're a leader. What are most people putting in terms of obviously this engineer that I copied from, had a ball valve, and then he had a needle valve. Now I don't know. Did he have the ball valve in there to protect the needle valve?
Let me say this too. We're not.
Did he have the ball valve? I understand.
But usually a ball valve is operated full open or full closed.
Yes.
We should never throttle with a ball valve. It's open or closed. So that's one of the big deals about this product is compared to. Let me say this. I worked with Atlantic Gas back during the Olympics, when they had 600 vehicles on CNG service. And they did the fill stations as well, that were upwards of 5,000 PSI. At that time, we didn't have that valve. We actually had a smaller version of it, okay? And the orifice of that product was probably less than half of what this is. As CNG service has expanded, globally by the way, a lot of the research and preliminary work for this valve where it was not done necessarily for this country, but actually overseas.
Well, let's just be a sleuth here, okay? All right. The reason why you would put a ball valve, which would be open or closed, all right, is either you have pressure on the valve or you don't have pressure on the valve, on the needle valve. Right? So as I could see it, if you would have a valve in there to protect the needle valve, because the needle valve is sensitive and that it doesn't, and that seating against the pressure could be an issue for any kind of duration, or the needle valve, I don't know how the needle valve would be clogged, because if it could get clogged, it would get clogged whether it had a ball valve or not. So you either you put a ball valve in there to protect the seat of the needle valve, or you have, and if that's the case, then your rising plug valve would be would be the combination of a needle valve and a ball valve of sorts, even though you have throttling capabilities. A needle valve is not a throttle, it's just a flush.
Well, needle valves in our world typically used to control flow. Not pressure, they're used to control flow. Ball valves, once again, especially one designed like this,
Okay.
the internals of this valve, when you look inside the orifice of the ball,
Okay.
they're going to very much closely approximate the idea of the tubing feeding it. So we don't have a step down that causes turbulence that's going to reduce the CV, coefficient of velocity of that product. So when this is full open, which it should be open or closed, we got a straight shot through here. So we're feeding whatever you're trying to feed. The needle valve is just to dump pressure later on or clean out the coalescing filter, from what I understand.
So I could crack this rising plug as and I would not experience 4,500 pounds of pressure coming out. I could experience just a whatever the crack is.
Oh, if it's got 4,500 psi on the inlet side, you're going to see that coming out, but it's going to be in small increments. There's no regulator. These are not regulators.
Right.
Okay. So if it's got 4,500 on the inlet and you open it all the way,
but the thing about it is you're not opening it all the way. You're opening it at one. It's a rising.
Sure.
You have a control. The control is a seat. It's actually like this. It's a seat, and it opens up and it has to actually come through. So that is I guess it's more like a cone, as it were.
It is.
Right. It's a cone that provides that seating capabilities. So, all right. What's the advantage of this rising seat?
Take a look here. Just a rising plug. Yeah, the seat stays stationary.
I mean, in terms of life versus a needle valve. I mean, why would I use this instead of a needle valve?
It's a personal choice of where the engineer did. Some of the benefits are it's easily rebuildable if need be. When it's in the open position, you'd have a higher CV than a standard needle valve, because the needle valve, the flow comes in, down, it's a glow pattern, up at the stem, down and out. This, basically it's a straight shot, and the plug basically is getting in the way. So by opening it up, the plug basically, that's why this is full open. It's going to have a higher velocity, higher flow rate than a corresponding needle valve at the same size.
Well, I've got a maintenance man who comes to my place, and part of his bi-weekly, tri-weekly operations is to go through and to test each needle valve, open it, go, let it, whatever it is whatever in the coalescing filters that is accumulated, blow it out, and so that the coalescing filter does not accumulate anything. That would be standard operating procedure. In most cases, these things are not operated, and that's an issue that I have. I want to. So here, a couple of twists, it bursts. A couple of twists, it's closed, and he's gone. Right. So the question comes down to is two things. One, all I'm trying to do is to blow out my whatever accumulation that I have in terms of vapor or it's gravity on here. The water flows to the bottom. It may have pressure on it or whatever vapor. It may be only a drop, but as soon as I open this thing up, it'll become vaporized. But it'll blow out.
Okay.
All right. So. I don't have a preference. I'm trying to determine why I would want to use one over the other. And I'm trying to get you to tell me why one is better than the other for a specific application. That is to blow out any accumulated vapor or water comes when it gets compressed, falls out of solution.
Yeah.
And that's what's going to happen here.
Well, it's a straight shot. Okay, you're going to open it up. If you go to full open, you would be able to evacuate that area more quickly than a needle valve that has a smaller CV.
Well, I don't want to pull it all the way open because it's going to be a lot of gas.
Okay. Where did the part number PD come from, by the way, Lee? Was that something that?
Out of the sample spec here.
Okay. Once again, I'm not trying to deflect the question.
No.
We don't design systems.
I understand.
If somebody here has figured out that this is probably the best thing for what they're trying to do. I think either one would probably take care of the initial request to vent the coalescing filter.
They're called out as drain valves on filters, vessels, and throttling valves.
Yeah.
I see 3 vessels with.
They're very similar in function.
There's 8 or 11.
You know, actually, Lee, I was going to say, if you want, you can maybe grab one of the small. We actually have a needle valve in program. You know, in the little small blue, black cases.
Isn't your needle valve going to have to go through the zigzag to get out of there?
It is. I'm going to go have him get
So if
one.
you're going to blow something out, it seems to be preferential to blow it out instead of zigzag through a needle valve.
That's
Okay,
right.
I agree.
Okay. Also, depending upon what stem you select, okay, there's a V stem, there's a regulating stem, there's a soft stem. You know, this, when it's open, we're not going to have a lot of stuff getting snagged in here.
I see that.
Okay, that may be the reason he did it. Now, I'll tell you one thing, once again, I have not had to deal with the CNG world a lot over the last couple of years. It kind of went away for a while.
Yeah.
But I can tell you the gas was a lot of times very dry and incredibly dirty. And so there was a lot of trash in the line, from what I recall, from 1996. And it was, you know, it was just, it wasn't like we were doing at a lab at Emory. Okay? Now, once again, because of this design with the tapered plug and then the tapered receiver, we do, this has a little more forgiving on trash in the line than a standard needle valve that's going to be counting on a metal seal. Okay, that could be one of the reasons the guy selected it. And it's the fact that you can drop in a new plug and you're good to go again. There is some ease of maintenance of this particular product versus a standard needle valve.
So is the cut sheet in this or this?
EDTR for that?
No, there's no cut sheet for that on there, but I can send you one.
All right, I specifically, no, I'd like a cut sheet on this, you know, a PDF file sent to me and to the group
On
this,
I think I did do it.
versus your needle valve, all right?
Yeah.
And right now, I definitely understand, and I think that this is a most appropriate approach to take for flushing out.
Here is a more standard, what we would say is a needle valve. Now, a couple of things to keep in play here is, there's a directional arrow, so the flow is going to be coming in here, going down, up at the stem, down and out. So if I was really worried about controlling a certain flow rate, okay, this is a better valve to control a flow rate, which we're not really trying to do here. One other thing I'll point out too is, once again, the packing for this valve is up in here on the stem. So therefore the threads are part of the wetted system. Right now they're kind of like coated with molybdenum disulfide. And I think that's probably going to be okay for that, for what you're doing for a long period of time. But this valve, the stem threads are above the packing. So the stem threads will never be subjected to that high pressure gas. They're actually separated. And we make a big deal about stem packing location relative to threads. Once again, if it's in a hydraulic system, it's good for the threads to be part of it. If it's in a steam system, it's a bad idea. So that may be also a consideration of the engineer who did this. That's a cutaway of what we would call a needle globe pattern.
All right, so from what I'm hearing here, all right, as far as control is concerned, I definitely want some control, because I don't want it to blow out a whole too much. All right, I don't want to have too much, but I want to have it as clean as possible, so that when I open it up, one or two turns, I open it up and I remove everything that's in the coalescing filter at the
Okay.
bottom of it. And now I'm assuming that I'm going to need probably some sort of nipple in between my coalescing filter and this. You know, there'll be some sort of nipple on that, but I won't need a nipple on the exit side.
No, not.
Unless you want to direct
All right,
it.
now as far as
That's right.
this is concerned, I can understand why, you know, they're talking about some sort of fine, very fine amount is concerned, but it almost sounds as if this could clog. This could be a maintenance issue.
Look at the flow pattern versus what we
No,
have here.
no. So this could be a potential maintenance issue over the long term, whereas that would not
Then
be.
you might want a ball valve
Huh?
in front of that one.
Yeah, so that you can take this out
Right.
and clean it.
Right. Whereas you
Wow.
got.
While that is the valve.
Mhm.
Okay, you convinced me. That's good. That makes the most sense in terms of a needle valve application for a coalescing filters. Don't you
But you
think?
got, in the valve world, you got metering, regulating, throttling, ball. If you were to look at it from that aspect, metering is when we're doing like cc's per minute, okay? Regulating, throttling. People try to throttle sometimes with a ball valve, but they shouldn't do that because the flow gets directed at the seat, and after a period of time, the seat goes away, and then the valve doesn't shut off. Okay? But there are certain applications where definitely the rising plug valve, there are some benefits here. One other thing that this valve does, by the way, is if you notice when you take this valve, and you actually rotate the handle, the shaft, the whole thing spins. This valve actually has a little knuckle joint. So when you turn the handle, the plug that actually makes the shutoff doesn't spin. It closes perfectly straight, okay? So there's some benefits there regarding not grinding stuff into the rotary motion into the seat. That's one of the other kind of cool things. We actually use these a lot, like on, once again, kind of a dirty system. Sometimes paint systems use these valves because the lubrication is not part of the system, as well as, if it's like metal flake or something like that, that seat actually can absorb a little bit of that stuff and still make a shutoff. This, if you mar the seat, you've got to put a new valve in. There is no rebuild kit if you screw up the seat on this. Okay, there is on that.
Has he convinced you?
Convinced me this is the better application for the needle valve.
I think so. I agree.
And I'm not sure we need the ball valve.
Oh, I think the ball valve is gone.
Okay.
I now understand why the ball valve is there, in order to clean the needle valve. Because the needle valve, apparently this is new, this is a reasonably new
No.
application for this
Well, it could
process.
be, I wouldn't know that. This valve, I got here in 1984, and we had these when I got here.
Uh-huh.
Now, one thing that we see and I'll give you an idea and I'm working on one right now with a paper mill, is they sometimes will have two valves in a row. And then the ball valve stays open all the time, and the blowdown valve for steam is the one that takes all the wear and tear. And when you do want to basically change out the last valve in line, you have the ability to turn the block valve off ahead of it and still have the plant running.
Sure.
If you only got one valve and it screws up, you got to shut the whole thing down.
So we're talking that these things are reasonably equally they cost about this similar.
They're similar.
In terms of cost?
Look it up. Yeah, they're similar. But that may be
You're
why
talking
there's,
in the range of $50.
yeah, maybe a little more than
A
that.
little more than that.
Did I miss it?
No, I would think it
I
probably
think you
would.
did the way you looked at
118.
each other.
175, 375.
118.
I can tell you were
I
wrong.
mean, even though we're in sales, we
That's
usually try to tell the
plastic.
truth
That's the
here.
plastic version.
I can't do this for 29 years.
You were looking,
That's
yeah,
the
you were looking
$50
at bleed,
model
you were
right
looking at
there.
the bleed valves, that's an honest mistake.
113.
Oh, okay.
Yeah, what do you have there for a 4 PD?
Ballpark.
113.
Okay.
Oh, okay. So what are we
It's with a male end on it.
what are we talking about? Bleed valves.
Yeah.
Okay, now bleed valve is something different. I don't know if we have any of those in here or not. Lee. If not, I'll pull it up on the, you know what? The basic concept will be here, even though this has got a tube adapter in. Let me pull it up on the iPad. But was it a BV?
Yeah.
Okay. Wow, okay. Well, if I was really strong and hadn't been on the road for 5 days, I can probably open this, but. let me
Ed is
pull-
very strong.
Yeah, take over. I'm not even sure what city I'm in at the moment, so.
Welcome to Jacksonville.
Yeah.
Here's your bleed valve. Is that what you want to
Yeah,
show?
all right. Now a bleed valve, once again, the inside, this actually has something called a tube adapter, which allows us to plug directly into a Swagelok fitting. In their application, what are we using, Lee? Is it pipe end or?
They all come with pipe ends.
Okay, except this one. But basically what you have going on here is a hex on the top. Yeah, this is a slightly different. But inside what we have going on is a metal seat, okay? And you tighten this down with either a T-handle or a wrench. And it's either on or off just a little bit. All we're trying to do is burp the system. You know, if it's a liquid system, you put it on the top to bleed the air. If it's a gas system, you put it on the bottom to get rid of the liquid. And there is no packing here, by the way. These are relatively inexpensive because you're just going to crack it and you're going to vent out the side and then you're going to snug it back up again. All right?
But they don't, in the high pressure, they don't make it with a tube in that goes
Yeah.
directly into a
Yeah,
Swagelok fitting.
I don't believe that's the case right now. This is actually one that's got a soft seat in it, probably. But it's the most basic of valve products that we make. There's no packing. There is no Teflon seal. There is no PEEK stem seal. Basically, you just crack it. Yeah, that's actually a purge, not a bleed. I'm sorry, that's a purge valve, not a bleed valve.
That's that he's holding them.
Yeah, but the bleed valve is what's on the screen.
Okay.
But they serve very similar purposes. They're very, very simple. And usually they're always in the off position. They're always closed. They almost never get opened unless you're trying to evacuate, like say liquid, trying to get rid of the gas at the top gas, getting rid of the liquid at the bottom.
But, so you're proposing to put a T, a half-inch T, and then you're gonna go from a tube to an NPT female fitting out of the T.
Once again, I referred to this, which stated that you could not put a union T in the system and then include pipe threads with it. So I've included a T with a tube adapter, and then you're going to screw the bleed valve into that.
That's how I want to make it.
I can send you
I
a sketch of what that would look like.
So show me the
What's it
drawing.
gonna look, is it gonna be a reducing T or a full half-inch, or can you, how's that?
Oh, okay, all right, so I got you now.
So we got the thread and female. The bleed valve,
Actually, it would be a full-size T,
full size.
a full-size T.
So it's a half-inch T.
With half-inch T, and then would have a half-inch tube adapter or a tube stub by female pipe thread, 1/4. 1/2 inch, pardon me.
Half-inch.
And then the bleed valve would screw into the tube adapter.
So the bleed valve
Okay.
is half-inch?
This is a tube adapter, right?
Yeah, it's a SSBVM8.
Okay.
And then, like I said, it forbid the use of,
So you have a full complement, do you have the bill of valves, that you marked that up? Because you didn't
Well,
get that to me,
changed
huh?
today.
I did, okay, right, so I guess we'll trade,
Yes, as a matter of fact, there's a schedule, I have it on the schedule on that drawing you took,
okay. Okay,
the number of each minus the changes we made.
well,
today. So that's clear now, I understand this.
we're only the high pressure valves, so, you know, not, these are all low pressure valves. The ball valves love it. The needle valves, the bleed valves, I totally understand it. We're not gonna, we need, what is the correct term for that?
That's a rising plug valve.
So can you change,
I have
okay,
the
would you
numbers-
put,
I have the numbers on the drawing you have.
okay, would you mark that one up though, where it says needle valve, put in rising, right there. Rising plug valve. So needle valve equals rising plug valve, okay.
For today, yeah, absolutely.
Well, no, I have to change the drawing. I'm not gonna put needle valve on it, I'm gonna say rising plug valve.
And Lee, once again, we're gonna be sending it to you, or have we already done that on the PD literature for these gentlemen?
you know what, I'll send it again.
Okay.
I think I sent a little bit, a lot of emails been flying around.
Yes,
These guys get buried
I
in
have
emails.
seen this,
I didn't see the plug valve.
You didn't
I
see
saw
the-
this
I
right
bought
here.
everything that I copied here.
Yeah,
Okay.
I missed it if you sent it.
I apologize.
We can deal with that.
What, over here at the gauge, what are we doing over there? We're gonna come off the line with, T, then reduce right away to 1/4 inch. What do you
Now,
say?
and the question here is, why do we need 2 needle valves? Why would we need 2 needle valves?
One that's for calibration.
Huh?
Are we using that to basically, here's your shut off and here's your bleed, so in case you wanted to change the gauge, you shut that off, bleed the pressure and take the gauge off? Like a block and bleed?
So why wouldn't that be your rising plug and this, they're,
Yeah.
why would you have, all right, so we,
Well, sometimes, I don't know, the gas company does, but sometimes people will come along and put the check gauge on there.
okay, so would a needle valve in that instance be applicable if we're talking about fine control?
Well, a benefit to having a needle valve in this application, in my non-important observation is, a ball valve, when you take a ball valve and you open it, things happen quickly. And the gauges don't like to be hit with high pressure quickly. So if you had a needle valve or a rising plug valve in that application, when you crack it, the gauge is going to do this. If you put a ball valve there, it's going to do this.
But we're not putting a ball valve there.
Okay, just that's something to consider
I mean,
here.
the question here is, the one that's on the vertical,
Yeah, well, that's how you're gonna, if you
right
have to
here, the
change this
vertical
out.
is a rising plug,
Oh,
and this be your needle.
We could save a little money with 2 needles and not hurt a thing. The pressure equalizes no matter what it goes through.
That's right, we're not worried about flow here, we're just measuring pressure.
Yeah, it's a dead
It could be a 1/8 line for all we care.
2 needle valves is probably the least expensive way to go. And
Okay,
if you
so-
need- If they want 2, it's kind of up to the gas company, they can live with 1, but if they want to do some kind of a test gauge, they go out there and screw in a test gauge, turn this one on, turn that one on. Can do that.
You know, we might actually, I have that, by the way, Lee. I have
You
the,
guys used to make manifolds for that purpose.
we actually have,
Okay.
we actually may have something that would help with that.
A double block and bleed
Or just a block and bleed, the little, what's the max pressure of that? What's the max pressure?
5,000.
4,500,
Okay,
5,000.
let me think about that a minute. We may have something in one piece that might be helpful to you, where it's kind of a built-in needle, and then you shut that off, and it's got a little tiny purge valve on the side, and it's built into one unit. That might save some money here. It's in one piece. So I've got one in the car. I need to verify the pressure rating. You know what I'm talking about, the RP?
Yeah.
We'll get back to that.
Yeah.
We may have something that can help you.
I've seen-
So the gauges themselves, you don't do or you do?
We do the gauges, yeah.
Okay,
There was a question regarding the safety factor, however, that we haven't totally doped out yet on the gauge.
It's the safest one we have.
Yeah,
Glycerin fill.
Gilson fill.
yeah, and it's got the, it's called a
Blowout.
safety gauge that
Blowout.
blows out the back and the safety glass and all that, sure. Now, typically when we're doing gauges, of course, you want the gauge to read in the middle third of the gauge. That's how people get screwed up all the time. They got a 500-pound system, so they buy a 500-pound gauge. No, you want to buy a 1,000-pound gauge, because the middle third is where the gauge is the most accurate, as well as we don't want the thing pegged all the time. Gauges typically, like ours, are made to handle up to 130% of the pressure range and still function.
so you're saying a 10,000 PSI,
6,000 would be the minimum.
Yes, a 5,000-pound system, we probably,
4,500 pounds.
we would look at a 10,000.
all right, so 4,500, I see, so.
6,000 would be the minimum. And that'd be a good range. 60% of 6. 70%
Yeah.
of 6.
Here's the pressure gauge right here.
You didn't quote that,
Once again,
did you? Are you missing a sheet again? I have a,
if you get a cut sheet, there's the gauge right there.
okay.
0 to 10,000.
We did a 10,000-pound gauge because it's going to read, if the normal operating is 5,000, that would put us virtually in the middle of the program.
Well, it's 4,500 would be.
I can send you
Okay.
this catalog cut too.
Similar,
Well, actually 4,500 is the top. It actually will, it probably will vary between 2,000 and 4,500.
Okay.
Okay.
You know,
This isn't gonna go higher.
because we're actually evacuating the system by dispensing.
Okay, yeah, I got you.
And
bleed it down by using the gas.
you know, and then you know, the thing is going to turn off.
2.5 inch. Is that what this
I'm
is?
listening.
There's the pressure gauge right there.
Mm.
I wasn't sure what size the face was,
Oh,
but I was looking at the size of the system.
There isn't a whole lot of cost investment in this in these gauges, are there?
It's a safety gauge.
125. 125, something like that.
It's because it's a safety gauge. It calls out for one.
Well, let me just define in a very
We're talking about
rhetorical
quality.
fashion what I'm looking for in terms of quality. I want a high Buick, not a Cadillac, just a high Buick.
This is a high Buick.
Yeah.
A Cadillac would be like a test gauge or something like that.
No, I mean I don't need to have it, you know, gilded, but I mean I want high Buick, you know, I want the bells and whistles that make sense.
Okay.
And so that's what it seems like where we're going.
Yes, sir.
I question, I question why we even want to go with any kind of needle valve. You know, even on this.
Just to save money would be the only thing where you could on gauges.
Well, see, the thing about it is that if we keep this simple,
Sure, you got replacement parts and
you know,
duplicating.
if we keep it simple, where we have the least number of types of valves, like the ball valve is always the same for this
Sure.
half inch,
Right.
all right? And as it turns out, okay, as it turns out, even if I wanted to go with 3/4 inch tubing, I'm gonna have two half inch pipes. Two half inch tubings, because you can't. I'm not gonna put 20 foot of stick in and then have some sort of access chamber. You know, so I'm interested in trying to create universality and commonality, standardization, and I'm assuming at some point, you know, I actually heard volume discounts, you know, so that if I have, if I buy a lot of the same thing, that I can have them shipped and the like, and it becomes reasonably idiot-proof. Green side up, green side up, green side up. That's what you tell your landscaper. Green side up,
How do we
green side
install
up.
this sod, you know? I remember my dad telling me that at a sod party one day, yes.
So why do we even want the needle valve? I mean. Now this will, the thing about it is also this may be a signature that I really kind of like. You know, that some people have a certain signature in the way they pipe, and if you're in the business, you sort of know, and others don't because of the way they do things. Now, when I was a young engineer, when I came to this town, you know, I did things and then I got copied. But there was a time where I was the only one who was doing a certain drain. I used PVC T for a drain structure or whatever, you know. So that, but be that as it in a pond. And it already had a vent, you know. So the T was.
The rising plug doesn't come with tubing.
No, it doesn't come with tubing nuts.
And the needles do.
All right. So the question comes down to how do you do the threads?
Well, they're gonna have a fitting, they're gonna be a tubed NPT fitting that we buy from an adapter, they call them adapters, tubed NPT.
So and that's going to be the case for every valve.
Not for the ball valves, but for every rising plug valve.
Yeah, that's correct.
They only come in threads. This one,
Mr. Smith.
that's what I was getting at. The needle valves, we can do tubing, and of course, these specs keep calling for minimizing threads.
Yeah.
So that's one advantage with the needle valves. They do come with the Swagelok tube ends that are.
It's integral, it's part of the body. Thank you.
Yes. Okay. Now I see where you're coming from.
One advantage. This would be even better if it had tube ends, but it
Yeah,
doesn't.
it doesn't. A valve like this is another cutaway. But when we're talking about integral, here's the valve body, and here's the Swagelok fitting on the end of it, part of the valve body directly. We don't have to make a conversion. I can't answer why that is. It's just, that's the way they've always been. And actually, one of the reasons this is relatively cost effective is this is just a piece of our stock.
Yeah.
Okay, it's relatively easy for us to make this.
It's strong.
And, you know, that's just how we do it. I'm sure other people have asked.
But we gotta have threads, you know, or coalescing filters, your equipment is probably, we're gonna have to have, but these specs that you've sent.
How about T's?
They say little as possible for threads.
How about T's?
They have the 2Ts.
Yeah.
And then when we do the 2T, then we put a fitting that has a built-in tube that goes into it's part of the pipe thread, has a tube in, goes into the Swagelok fitting, gets swaged down, well, not really swaged, but ferruled down, and then you put your gauge or whatever right onto that fitting. You have those minimal threads, maybe one at each connection to the side of the.
Let's talk about threads too for a minute. Once again, you're absolutely correct. You can't get away from having some threads in the system. It's just that's how it is. A couple of things that can be done to help with is to make sure that we're using the correct Teflon tape thickness to deal with stainless steel threads. If you're going to be buying Teflon tape from Ace Hardware, that's like 1 to 2 mils thick, and it's made to be used on PVC and brass. On stainless steel, we make something called strip tees, but other people do as well, but it's 3 to 4 mils thick, and that extra thickness keeps the tearing process to a minimum. And keep in mind, with stainless steel, there's an awful lot of shear strength between those threads. The thinner stuff gets torn very easily, which doesn't provide the lubrication protection on the flanks of the threads, as well as, you know, it tears
So
and the
it
bits
gets
and pieces get blown downstream.
So yeah, so it actually ends up in the coalescing filter downstream where it has to be blown out, right?
Yeah. I know we're going to talk about training as well. I think today it's one of the reasons we're here, and we cover that a lot. I just covered it at the Navy earlier today. We're actually working with the NAS, a lot of people are retiring there, and a lot of young people need to be updated as to how to do a lot of this, because it's becoming a lost art on how to bend tubing so we don't have lots of little pieces in the corner that didn't come out right. Same thing with Teflon tape on the threads. I've got a valve out in the car right now where somebody screwing around on their desk took actually a bigger version of this and put a thread into it by hand and couldn't get it out. And basically they galled it, and a $450 valve went down the drain because once they did get it apart, the threads were damaged, and since it's going to be in steam at a couple hundred pounds, they couldn't reuse it. So Teflon tape is really critical. When you get a male pipe thread from me, our company, if it's a male thread, 1/2 inch or smaller, these threads are actually cold rolled, not cut. Okay, and what that means is there's a stub, and these threads actually get compressed onto the stub. So the grain structure of the material follows the thread. Unlike if it's cut at the top of the crest of the thread, it's unsupported, and you can shatter and things like that. So a lot of effort goes into making pipe threads the best we can possibly make them, so they basically exceed B120, which is the governing body for pipe threads. So you're going to have them, but if you're going to have them, don't go cheap and get something at Joe's discount shop, because it isn't going to work, especially on high pressure gas.
When you do the training, you hand out material, everything you cover is in a little manual, and the guys will get to keep it, and of course we want to help.
Yeah, we have a range there. Now,
But before we
Okay,
go into
yeah.
the training aspect,
Yeah,
I
yeah, we may be
wanna-
getting a little
I want to
ahead.
let me just touch base with the thread concept and this, you know, the rising plug. You know, this is the damned if you do and damned if you don't scenario, and I think we have to the lesser of two evils, as it were. I actually believe that it's going to be worth the thread aspect on, you know, because of there's already a thread.
Yes.
Right. Now, as I understand it, the coalescing filter has a female, and you actually put in a male coupling in it, all right? This male coupling will also go into would also be it would be kind of like a union, or a nipple of sorts, kind of like a nipple, but it'd be the male version of the nipple instead of two females?
Yeah, they frown on nipples in these systems, but that's what it would be. It'd be a nipple between the coalescing filter and the rising.
Yes, that's what I'm seeing. I see a female with the threads. Then I have a small little bar stock that's just basically just a threaded nipple.
Yep.
And that's what I'm tying into those two, and that makes it reasonably okay. Now, as far as the one place where I'm going to have a valve and some sort of pressure, gauge. This pressure gauge location is going to be very close to the proximity that I have for my priority panel. Now, I don't know yet, as of yet, whether or not that I will have that included. Right now, I'm working with Colby to provide my coalescing a large portion of the valving assembly here on a unit strut that they would just pre-construct, and so I can just put it on my
Prefab
units,
unit.
prefab and the like. So I don't. I'm trying to keep this as simple as possible, but everything that we're going to make a decision on, Colby's going to look at over our shoulder. So when I send him the information, he may be calling you.
Okay.
To discuss these
And
issues.
where are they located?
Buffalo, New York.
Okay.
Buffalo, New York. They do a Gemini, GE compressor package.
All right.
So they're our supplier here in this, and so in any event, this gauge package, I want to make certain that it's prominent, because it's going to be the first thing that somebody's going to look at. How is it operating? And this gauge is, how big is it? What's the face?
2.5 inch.
Huh?
How big? 2.5 inch.
Yeah, what would you like it to be?
What would you like it to be?
Well, if all right, you're a maintenance guy, all right, and let's say I'm having you go there in the middle of the night, okay, with a flashlight or turn on the lights, all right. I want him to look at this, Is there?
Did it call out a gauge?
Is there any of your gauges have telemetry connections?
I'd have to look into that to see if we could do something along those lines. We do have the ability to have like contact points, okay? But if you're looking for a live data link,
Well, see, I'm going to have a live data link for my control center, my motor control center, even though I don't have a motor control center. I'm going to have some sort of, linkage, because I've got a system, and if it goes down, I want somebody, I don't want just some horn, or some red light. I want somebody to be notified and pick up the phone and call up a maintenance guy to go and take a look at what's happening. But more importantly, I'm wondering if I'm going to have a gauge, and that looks like the only gauge that I really have in the entire system,
Yeah.
if I could have telemetry on it.
that we'd have to ask. We